our shear. This is the shear we did last time. And we have the ASP, the parite boundary. So if I slice it and look down, change to gold.
This one, I wasn't part of it.
Mm. Yeah, so this is what we did so far, and we move to the lows. As you can see, the hanging wall and the foot wall shear, which
Yes.
okay, sorry, we had a visitor, so this is what we did the last time. We are going to continue with the lows today. So let me clear my screen and bring our mesh table for the lows. These are the selections. The selections we did. So we are going to use these selections to model the lows. So that's what we're going to continue today. So when you get your selections this way, what you need to do is to model the lows, or we call them wireframes, or we call them domains, whichever you want to call them. Is the same. So you go to geological model. It's the same way we did for the ASP, same way we did for the shears. So new geological model. If you remember, the base column for the parite boundary was select parite, and the base column for the shear was select shear. So now the domains that we did the selection the last time. So the base column is going to be select lows, or I could have named it domains, whichever I want to name it. Okay. So the surface resolution. We said that the surface resolution are measurements of the triangles, the length and breadth of the triangles. So if you say 300 as surface resolution, means you are going to get the wider triangles. So we don't need it that. So you can just put it 10 for the loose. I explained that if you click on the adaptive, wherever it is necessary for it to form final triangles, it will. For example, edges. So that is the essence of the adaptive. when you come to the enclosed object, it's just talking about the extents. So we already have the ASP or the parite extents, and we have the shears extents, which they are the same. Remember, we created by adjusting, we created the sulfide boundary by adjusting to get the extents, which we were satisfied for that. And when we're creating the shears, we chose the extents of the parite boundary. So they are the same. So whether you take parite or the shear extents, they are the same. So I'm going to give this place domains. That's what I want to name it. So with this, you click OK and allow it to run. I want to freeze an object here. I want to freeze this. I was running something, but I want to freeze it. So I'm just going to freeze this so that this domains will run faster for me since we don't need this one now. So it's either you freeze it or you just give it a priority. So when you come here, so run priority only. This. I don't know if you follow the recordings and then you have questions. Once it's running, you can bring it up for us to discuss. I want to take this one for the purpose of our. I want to take this one off so that it will run faster for us. Okay, so it's done running. So this is the model you've created. Before you go on, these are, I think we identified three domains over there. So we need to create a geology, or let's say a lithology, to host them under the veins, because those domains are actually coming from a lithology. So to do that, you just double click on geology, or sorry, lithology. If you double click on lithology, come to art. Just give it loads and then you okay it. So you've added a domain or a load in it. That one is just because it's vein. You will be setting vein interaction because at the end of the day, the veins should be crossing each other. So you just want to terminate some of them. So you need to create that one to host the vein so that you'll be able to set the vein interaction to terminate areas that are crossing each other away. So when you do that, you come to surface chronology and right click, you come to new vein. And in the new vein, you're going to choose the load you've created. You can leave this as load vein system, or if it was domain vein system. Then you say, okay. I think I selected, I gave a priority, so I need to clear the priority so that it will run whichever is it. So you now have this. So this load vein system will appear empty and inactive until you create something on it and then activate the surface chronology. So when you right click on it, so you go to new vein from base lithology. Now, these are the selections that we did. Footwall domain, hanger wall domain, main domain. So the main domain was at the center of the shear. The hanger wall domain was at the hanger wall of the shear, and then the footwall domain was at the footwall of the shear. So you create that one first. So you select it as vein lithology, select it, and this is the name, footwall domain, and you okay it. It will run. Let me increase the surface resolution for it to run faster for us, so that when you finish editing your wireframe, you can reduce it to get normal triangles. Because the smaller the resolution, the finer the wireframe. The smaller the resolution, the finer the wireframe. And the longer it takes to run. The smaller the resolution, the longer it takes to run. The resolution also depends on the wireframe. If it is too big, like the ASP boundary or the sulfide boundary, you put a bigger resolution. If it is small, put a finer resolution. If you are modeling graphite, which is very thin, you can give it a resolution of 5 because that one is very thin. But it takes a long time to run because it is running series of triangles. Let me give it 20 so that's when we finish the wireframe, then we can change it back to 10 or even 8, depends on the wireframe. The center, the main domain is bigger than the hanger wall and the footwall domain. So that one we can give it 10 and then give the other ones 8, 8, the footwall 8 and the hanger wall to 8. Depends on the Depends on how big the wireframe is. Okay, so if you go back there, it hasn't finished running yet, but we're just creating them for them to run. Go back to the load vein system, go to new veins from base lithology. You did for the photo wall, so go to the angle wall and okay it. Go back there, load veins and then new veins from base lithology. Then you select the main domain and you okay it. So you have your veins created under the vein system. So they will all run. So it's about 32%. We have 160 items running. So each of the domain is going to produce a hanging wall on the foot wall, then produce the segment, that's the point, the sample points that links the hanging wall on the foot wall. Then every domain has a reference surface, and the reference surface mimics the strike of the domain. It shows the strike of the domain. The footwall domain boundary is just it is like a polyline where you if you want to edit, if you want to trim down the polyline, then you just use that one to trim only that domain. So every domain has that. A hanging wall and a foot wall, then the sample points that it has used to form those hanging wall and the foot wall for forming the solid. Then this pinch out is when you're done your major domain, which is continuous. Usually you don't pinch it out. You identify your major domains that is continuous. You don't pinch that one out. But the smaller ones where we have a lot of sample spaces, when you pinch it out, you take out wireframes from where there are no samples. So that's the purpose of this pinch out points. Taking out wireframes from where there are no samples, because leapfrog takes sample from far away and join two samples that are from far away. They join them together. So the in between those two drill holes, you don't have data at that moment. So you pinch them out. Anytime you have data, then you update that portion. And the reference surface is just showing the strike of the ore body. Then the boundary is just if you don't have topo, you just want to use this one to just digitize a string around the wireframe to chop off areas that do not have samples. That is the purpose of the boundary. And it's like that for all the veins. The vein will appear empty until you digitize around you use it to digitize around your ore body, produce a polyline in it. Otherwise, it will always remain empty. Okay, is that running? So This is what you get in. You see that it's odd. See how it is. You need to edit them. So before you start editing them, they are supposed to be inside the share. They are supposed to be inside the share. Whatever is outside there, you don't need them. You don't need them. So you have to constrain all your domains inside the share. Whatever is outside is waste. It's just a projection from leapfrog. So to do that, you go to under the domains, the boundary. Right click on it and go to new lateral extent. Then from surface, you go to boundary. Right click, go to new lateral extent from surface. Now you browsing to select your share. This is your share surface. Take that one. Then observe what will happen. When you see the surface chronology, it's just trying to tell you that it's just telling you the order of the position or the order of formation of the various domains. So your major domain, which is the main domain, should be the first order before the smaller ones. So it is assumed that your main domain is your primary halo, which deposited first in between. Deposited in between the hang-wall footwall share before dispersion began, and that kind of secondary halo came into being, which is the minor ones, and further erosion of the deposits gave birth to whatever load is outside the shear. So take note of the primary halo and the secondary halo strategies here. Are we there? Hello? Hello?
Yeah, hi.
Okay.
Yeah, Clint, you are there.
Okay, so you've seen that those waste that was outside is gone. The outside waste has been trimmed off. So this is the domain that was at the footwall. end of the shear. And this one is at the hang wall of the shear. And this is the main domain. Okay, I want to take this one. I want to take the topo off so that we'll have it to be able to run faster for us. Topo to a factor. So usually at this is the stage that when you give your data to a consultant, this is the stage that you have to take it and then edit it yourself. Now, 40% of the work is done. What is left is you have to just ignore the hangover football points. So let me begin with the main one. But before that, you see, let me close this. This output volume. If you want to produce this output volume, double click on this, the chronology, then take this. Double click on the vein system, then take this. Over here, the surface chronology, the main domain has to go first. This and this can stay as where they are. So it means that this was deposited first before this and that. When we finish editing all the veins, then we come and set our vein interactions here. Okay, but if we want to, we can set it before we do the editing. It doesn't make anything. It doesn't make any difference. It's just that because the veins are interlinked, you have to exercise patience for it to run because it will take longer time to run. Good. So your output volume is this. Comprises all the domains. Run them separately. This is that. So the order of this, we are not done. We are not done at all. The work is 40% done. We are not done. So just want you to see the order. So that is that. I don't know whether you're thinking 3D. You know, when we are doing the first phase of exploration, we chase shears because geologically mineralization is bounded by the shears. The shears controls the mineralization. Before, so the shears in leaf rock is not the graphite or the chloritic shears that we know, but the shearing where I mean, between the contacts, they're sharing, where there's where there's the position, the contacts between the ore body and whatever rock is adjacent to it, they're sharing. That kind of shear that we're trying to interpret, where we have our domains. Okay, so let me set the vein interactions. So we have identified that this is our main domain. Sorry, the main domain is this. So I'm going to pinch this one out. So if you double click on it, double click on this, and go to surfacing. Drop down and pick all data. All data, because there are places that you will have to use polylines to correct the wireframe. So you pick all data and then snap to all data. If you pick drilling only, it will only recognize the samples. Any polyline you add, it won't recognize it. So that's why I'm taking all data in case I happen to add a polyline. The maximum snap distance is that's your surface resolution. So when you change the resolution to 10, it will come back to 10. Then you take this pinch out. So you pinch it out. You do same for this. Double click on it, surfacing. Select all data, all the way. Then you pinch it out. So those with pinch out are discontinuous. That is not the only pinch out you are doing. When we finish the editing, the hang wall and the foot wall editing, then we realize that there are still some portions that has wireframes, but no drill hole data passes through them. And the distance is too wide. So we can use the hang wall, foot wall to again trim off those places that we don't want. Okay. I want you to finish running, then we'll set the vein interactions. I would have finished the editing before I do that, but the editing takes longer time. So when we are done with this, then we know that what is left is the editing. And when we are done, we shall come back to do the lows that are outside the shear. Actually, we don't have enough samples that are outside the shear. Maybe because of training purposes, we just want to select some few for you to see. I intend getting complex data for us to model even up to the graphite and the metavolcanics for you to appreciate it. So to set the vein interaction, just double click the vein system and come to vein system. Then you add, select it and add. So this is our main vein. So that's. So usually setting the vein interaction is confusing. So if you don't know, and at times too, you finish setting and the vein, the hang wall will flip to the foot wall, the foot wall will flip to the hang wall. When it happens like that, your minor domains, you will not get wireframes. You have to flip them back. Okay, so let me pull out the main domain. And then I pull out the reference surface. I told you that the reference surface, the red aspect is the hanging wall, and then the blue is the foot wall. That is by default. The red portion is the hanging wall, and then the blue portion, the foot wall by default. So to set the vein interaction, I just have to know that, okay, this is my footwall. You see that this one has flipped, eh? This is my hanging wall. Okay, so this is actually supposed to be at the footwall. That's what that, or I think maybe I name it differently. I don't know. I have to check. Or you see that, let me pull this and I see. I'm going to pull. So when you create a vein newly, it is solid. So you have to take fill slicer. Let me show you what I mean. See that this place is solid until you take the fill slicer, it won't open. Can you see what I mean? So when you create the vein newly, that is what happens. Okay. So I'm going to pull this, and I'll pull the okay. Okay, I think I named them differently. So I can rename. Let me do this. Do this on footwall. No. Okay, so that's how I want it to be. So now I'm going to say that once the main domain is my major domain, I want the hanging wall to terminate at the hanging wall of the main domain. Then I want the footwall to terminate at the footwall of the main domain. So I simply have to double click on this and go to vein system, then click on the hanging wall, then I add. Now, let me pull this one. Okay, so now we have hanging wall domain, and this is our main domain, which is the main domain. So we are saying that this hanging wall, it should terminate at the hanging wall of the main domain. We are saying that this hanging wall that we have selected, it should terminate at the hanging wall of the main domain. Then we come here, then add. So we are saying that this footwall should terminate at the footwall of the main domain. It should terminate against the footwall of the main domain. So the hanging wall should terminate against the hanging wall of the main domain. There are instances you see that, okay, we have the hanging wall, or say the footwall being longer. So you can add your termination. Sorry, this. You can add the termination, but it is not like that in our case. Then you okay it. this. Okay. So in this case, no wireframe will cross each other. No wireframe will cross each other. So you are certain that whatever you are getting, I mean, if you estimate the main domain, you are getting only models inside the main domain. If you estimate the hanger wall domain, you are getting only models inside the hanger wall domain. So that is that. So now I'm going to start the editing. So if I have this, I just have to make it cylindrical, send this on to 2. Okay. So now, if you observe critically, you realize that even at the top, there are hanger walls formed there. So you have to just take off all the hanger walls at the top. You don't want any hanger wall or foot wall at the top. So I'm just going to select all these ones off. Then I'll make sure that at the hanger wall, at the foot wall side, there shouldn't be any hanger wall there. At the foot hanger wall side, there shouldn't be any foot wall there. That is the idea. So I just have to okay, let me just even start from where the data is intense. So I think I explained this one when I was doing the shears and then the parallel boundary. So when you pull the, first of all, this, it is here, main domain segment.
Yeah,
Somebody talking. Okay, so when you pull the main domain segment, just click on the pencil, edit vein. Then I just have to select this. I don't want what is on top. Is the way the drilling was done. So I just have to exclude them. Then the edges, I just pick them, exclude them. Exclude them. If you want it faster, you can just, if you understand the 3D, just have to do this. Exclude what is. Exclude them. Now, LeapFrog has made things easier. Those days that you had to select one by one, one by one, one by one. Ignore. Now you can just select them and do away. And exclude them. exclude, and you save. Okay. So when you do that, look down, then give a section. Looks up. I'll give this one 20. Okay. So I'm using the greater than, less than. But I'm stepping through. I can, you see, so faces. I just pick that. This one, just make it a string to be able to see what I'm doing, the points. So I click on this, show faces. So this is short. I don't want them. So see this one, the way it's passing through, I just have to take it off. So take this and this off. This one is shorter. Just have to take this. Using the greater than, less than to move. This and these are too close. So let me just take this off. So I think that place is, if you don't take the show faces back, you will not see the wireframe when you. So let me save this. I want to start from here. I want to take this. This one is not a selection whereby you can, I mean, you want to go by the drill spacing. I'm just ignoring handle of football points. You can undo here. So I'm making the wireframe transparent so that you see how the way the wireframe behaves and the reason why I'm picking them off. So this hanging wall, I mean the foot wall is pulling. So I just have to take it off. On this. Some instruction. So this was the short. I want to take them off. I want the wireframe to go this way. So I'll take this and that's off. I'll take this. I'll take this one off. This will go. This foot wall go. This hang walls go. Let me update the wireframe and see what will happen here. Yeah. It's time, man. So I can reactivate this, that, and that. That's here because of this space. So with that, I'll select O2. Guys, is this difficult? Hello?
Yeah, good.
Yeah, so that all what we are doing, that is what we do until we get a desired wireframe. And it looks like our time is up.
Yeah.
In order not to meet too frequently, aside, I think the vein modeling is the most I mean, the longest process, I mean, longest way of modeling and then the most difficult, but the rest are very easy. I wanted to introduce you to something, but because it's time, the remaining ones are just ignoring the hanger wall and the footwall. Where you think the hanger wall is pulling, so you ignore. Where you think the footwall is pulling, you ignore until you get a desired shape. What do you think?
But is it possible we could continue that tomorrow? But a lot of and I need time to go over the video.
Okay, that's fine. Okay, that's fine. So we continue that tomorrow.
All right, thank you.